Hey, it's Mrs. Weethy, and we're back for lesson 8 on boiling point. So when a liquid is heated to a temperature at which the particles throughout the liquid have enough kinetic energy to vaporize, then the liquid begins to boil, okay, which is different than evaporate. Evaporate takes place at the surface. Boiling takes place throughout the liquid. And so, that's a key difference between the two. Bubbles of vapor form throughout the liquid. They rise to the surface and then they escape. If you've ever noticed, when you're heating a pan of water, you have bubbles forming on the bottom of the pan, and those bubbles are actually water vapor. So as the water vapor forms, the bubbles of vapor are forming through the liquid. Because they're less dense, they're going to rise and then escape. The boiling point, then, by definition, is the temperature at which the vapor pressure of the liquid is just equal to the external pressure on the liquid. So external pressure, the pressure on the outside, so you have air particles that are colliding with and hitting the surface of the liquid. Because the liquid boils when its vapor pressure is equal to the external pressure, liquids don't always boil at the same temperature. And this is, so if you have liquids at lower or at higher altitudes, then the atmospheric pressure is lower, and so the boiling points are going to decrease at those higher altitudes. So take a look at this. We have at sea level, and we're at 70 degrees Celsius. So at sea level, there isn't enough pressure, there isn't enough vapor pressure exerted on the liquid, so bubbles of vapor can't form inside the water, and so it's not going to boil because the vapor pressure is less than that of the atmospheric pressure. But once the liquid reaches the boiling point, then the vapor pressure, okay, and that's the pressure of these bubbles that you have in here, the vapor pressure is equal to the atmospheric pressure, and so bubbles of vapor are going to form in the water and it begins to boil. Now if we take a look at Mount Everest at higher altitude, the atmospheric pressure is lower than the sea level, than the pressure at sea level, and so the water is going to boil at a lower pressure. Okay, so boiling is a cooling process very similar to evaporation. So what happens is the vapor produced is at the same temperature as that of the boiling liquid, but even though the vapor has the same average kinetic energy as the liquid, its potential energy is a lot higher. So it takes in, like, as it's heating up, you're increasing the kinetic energy, but some of that energy is transferred or stored as potential energy in the liquid molecules. And so they have the same kinetic energy, but they have more potential energy. And so what happens is, if you get burned from steam, you actually get a more severe burn from the steam than you do from the boiling water, because the steam has more potential energy inside it than the boiling water. So here's what happens. You increase the kinetic energy. Those water vapor, water molecules, let's say, escape, and so as they escape, then you have the molecules left behind that are at a lower kinetic energy. So it's actually a cooling process like we saw in evaporation. The normal boiling point is defined then as the boiling point of a liquid at a pressure of 101.3 kPa, which is standard pressure. And so if we look at all these different substances that we have here, we see that their boiling points are different, okay, because, and really it has to do with their intermolecular forces. The stronger the intermolecular force, the higher the boiling point is going to be. And so with that, that is the end of video lesson number 8. And like in my previous videos, goes. I want you to be happy, have fun, and dance. This is Mrs. Weethy, so long for now.